Good afternoon, everyone. Welcome to this roundtable on optimization in manufacturing and quality management through the theory of constraints, or TOC. For those unfamiliar, in a roundtable, each participant will have the opportunity to share their views on the central topic, followed by a space for final conclusions. Today, we will explore how TOC, an approach focused on continuous improvement by identifying system constraints, can be applied to manufacturing and quality management. This theory invites us to analyze bottlenecks and other limitations that hinder the overall performance of a production system. Additionally, we will discuss how process quality is fundamental to optimizing resources and ensuring a reliable final product. We have 4 experts with us: Fatima, a specialist in TOC and bottleneck management; Belen, process engineer experienced in managing capacity and limited resources; Abril, continuous improvement and control methods consultant; and Ricardo, quality control and standards complaints specialist. Let's begin with a question to open the conversation. What do you think is the importance of the theory of constraints in modern manufacturing, and how does it impact quality?
The theory of constraint fundamental in model manufacturing because it allows used to focus on the bottlenecks, the points in the production process that limit the total flow of the system. When we identify and address these bottlenecks, we maximize the resource efficiency and improve system performance in a manufacturing environment where demand and pressure to reduce costs are high. TOC provides a strategic framework to concentrate improvement efforts on the areas with the greatest impact on productivity. Additionally, the focus on constraints prevents from spreading records by trying improve whole process. Instead, targeting only those that generally affect the final outcome. This led to more effective use to resource, cycle time reduction, and ultimately an increase in the company's profitability.
Addition to what my colleague mentioned, unbalancing capacity is one of the most common problems in manufacturing. TOC helps you manage the dispatch. Imagine a production line where some processes are far than others. This creates accumulation at certain points and downtime at others, impatient efficient. To always use to detect the imbalance and work the synchronous process, balancing each stage capacity so no part of the system is overload or underused. This synchronization is crucial to maintaining a continuous flow and avoiding time and resource loss, resulting in a more efficient operation that can adapt more flexibly to changes in demand. Thus we can respond more soon to market needs without incurring additional costs due the, to production imbalance.
To complement what we said, I believe another major contribution of the TOC is this focus on the pain events and the statistical fluctuations which are really in any production process. In practice, each production step depends on the previous ones, and any delay or variation in one step affects the next. This can cause delays in deliveries, increase intermediate inventories, and lead to efficiency losses. EOC proposes solutions such as reducing batch size and synchronization processes to make production more stable and less susceptible to these fluctuations. In other words, it helps use minimizing the negative effects of variations, ensuring that processes flow more consistently and reliably. This not only improves system efficiency but also facilitates production planning and scheduling, reducing risks of the overproduction or excessive inventories.
Regarding quality, it's important to highlight that TOC also positively impacts this aspect. By focusing on optimizing bottlenecks, we can implement specific quality controls at this critical point in the process. This means that instead of distributing quality resources uniformly, we can concentrate efforts where they're most needed to prevent issues from spreading along the production chain. This way, we achieve a final product that meets quality standards and minimize the need for rework and waste. Improving quality also leads to greater customer satisfaction, as defective products decrease and delivery times become more predictable. Therefore, TOC not only increases production efficiency, but also ensures the final product meets market quality requirements.
Thank you all for your valuable contributions. To summarize, we see that everyone agrees the theory of constraints is essential for maximizing efficiency in modern manufacturing. This approach allows us to identify and manage bottlenecks, balance capacity at each stage of the production process, and handle the effects of dependent events and production variations. Additionally, you have highlighted how this approach benefits the quality of the final product by concentrating efforts on critical process points, reducing waste, and improving consistency and reliability in the production system. Now, I'll ask each of you to share a final conclusions of how TOC application can transform manufacturing and the role of quality in this process.
In conclusion, I believe the theory of constraint is a powerful approach for any manufacturing company to looking to improve its competitiveness by identifying and working on bottlenecks, more agile and profitable system in general. It's now just about producing faster but doing it smarter, using resources efficiently. The key lies in viewing production as an interdependent system and continuously improving critical points to maximize overall performance.
The conclusion is that talk helps use strategy manage resources, eliminating efficient action from unbalanced capacity. This not only leads to great efficiency and cost reduction, but also flexibility to respond to demand changes, transform manufacturing, be allowing use to adapt, kick and be more agile in competitive environment.
From my perspective, one of the TOC most important benefits is the ability to reduce the effects of variations and deepen events, achieving a more stable and predictive workflows. This helps meet delivery timelines and improves the system overall efficiency. In an increasingly demanding market, the ability to maintain production stability is a key differentiating factor.
I believe TOC focus not only on efficiency but also on ensuring the final product meets necessary standards. Will balance efficient production system, reduce the likelihood of errors and rework, resulting in a higher quality final product and more satisfied customers. TOC is an integral tool that optimizes resource and guarantees an outcome that meets market expectations.
I really appreciate each of your conclusions. It has become clear that the theory of constraints is a powerful tool for improving manufacturing efficiency and that it also plays a crucial role in maintaining high quality standards. With a focus on continuous improvement and prepared constraints management, companies can optimize resources, reduce waste, and deliver higher value products. I want to thank you and all our experts again for their time, insights, and all the thanks for joining us in this round table. I hope this discussion has been helpful in understanding how TOC and quality management can drive success in the manufacturing world. Thank you all and see you next time.